Let's dive into reinforcement learning from human feedback, or RLHF, and explore how it compares to standard reinforcement learning, or RL. So here's the idea. Standard reinforcement learning is great when outcomes are easy to verify, like math problems where answers are clearly right or wrong, or games like Go, where you either win or lose. In these cases, defining a clear reward function is straightforward. But what about subjective tasks, like writing a summary, telling a joke, or generating creative content? Here, there's no single correct answer, and creating an automatic reward function that accurately captures human preferences is tough. That's where RLHF comes in. Here's how RLHF typically works. The first step is generate rollouts. Given a prompt like create a joke about cakes, the language model generates several different responses called rollouts. Think of these as multiple drafts or alternative versions. Instead of developing a complicated scoring system, we simply ask humans to rank these responses from best to worst. Ranking is much easier than assigning specific scores, especially for subjective content. We then use this human ranking to train a reward model, which is a neural network that learns to predict human preferences. Essentially, this model acts as a proxy simulating human judgment. The next step is reinforcement learning with the reward model. Once trained, we use the reward model to guide further training of our original language model. Instead of relying directly on human evaluation or fixed objectives, the language model now learns to produce responses that the reward model predicts human will prefer. Now, let's clearly compare RLHF with standard RL. In traditional reinforcement learning, the reward signal is objective, measurable, and clear, like getting the correct answer to a math problem or winning a game. The model learns through trial and error, optimizing for a well-defined outcome. In contrast, RLHF has a subjective reward signal learned from human preferences. The reward comes from the trained reward model, not a fixed goal. The language model thus aligns more closely with what humans like, even without a definitive correct answer. Alright, so let's summarize the advantages and limitations of RLHF. Let's start with what makes RLHF great. First off, it's really good for handling subjective tasks. Think storytelling, summarization, or creative writing. These are areas where traditional reinforcement learning just doesn't work because there's no obvious right answer and no clear reward to go after. It also makes human feedback a lot more practical. Instead of asking people to come up with the best response from scratch, we just ask them to rank a few options. That's way easier and way more scalable. And here's the really cool part. RLHF builds human intuition into the training process. It helps the model learn what people actually prefer, even if we can't always put those preferences into words or rules. But there are definitely some challenges too. The reward model is not perfect. It's just an approximation of what people might like. Sometimes it gets it wrong or misses the subtle stuff. And language models are smart, maybe a little too smart. They can figure out how to game the reward model, generating answers that technically get high scores but aren't actually useful or meaningful. Also, we can't train forever with RLHF. If you go too far, the model might start producing weird, unnatural outputs. So usually, we treat it more like a final tuning step rather than an ongoing training loop. Wrapping it all up, RLHF is a powerful approach for aligning large language models with human judgment, especially for subjective tasks. It relies on human-guided reward models, making reinforcement learning applicable where traditional methods fall short. However, unlike standard reinforcement learning's clear objective goals, RLHF depends on learned reward signals, bringing imprecision and potential exploitation risks. While RLHF marks a significant advancement, it's essential to recognize it isn't a magic bullet. It's more of an intelligent tuning process with practical limitations worth keeping in mind.